Hi, everyone. It's wonderful to see all of you. We were just talking about how we didn't use all these technologies kind of before COVID, or I did not. And I think it's just wonderful to be able to talk to all of you in lots of different locations. So for those of you that don't know me, my name is Karen Steelman. I'm the science director at Shumla Archaeological Research and Education Center. I'm excited to be talking to you today about our newest research and preservation focus, the Hearthstone Project. And we're all in different locations. But I want to begin by acknowledging that no matter where we are, that the land beneath our feet is the ancestral home of many Indigenous peoples. And we revere and respect those who are stewards of this land long before it became our home. And, you know, with our work, we're hoping to strive to honor both past and living Indigenous people and their cultural heritage. Let's get started. The title of my talk today is the Hearthstone Project, New Data from the Radiocarbon Laboratory. And with this new project that we're doing, our goal is to build a chronological model for Pecos River style pictographs in Southwest Texas. So we can begin to understand when the painting of these murals began, how long the style persisted, and then when this painting activity ceased and was replaced by different styles of painting that are also found in the region. So our organization, Shumla, is a nonprofit research center. We're dedicated to preserving the rock art of the Lower Pecos Canyonlands via documentation, research, stewardship, and education. And this archaeological region is located along the Texas-Mexico border at the intersection of the Rio Grande, Devils, and Pecos rivers. We know of approximately 350 rock art sites on the US side of the border. And these are sort of marked on my map, sort of in general. And then we do know of 35 known sites in Mexico. I don't have those mapped, but we do know where those 35 sites are located. And presumably there are many more that we don't know about. So I showed this slide recently, but I really love this figure. So many of you are familiar with Pecos River style art, but maybe there are a few of you that are not. And so as an example, I've decided to highlight this single anthropomorph or human-like figure. It has, let's see if I can get my laser pointer to cooperate. It has wrist decorations here, and then it has a black, oh, it's not cooperating. The speed's a little off, so I'm going to take it off. But it has a black addle in its right hand. It's got finger loops and looks like maybe feathers or weights. And then in its other hand, it has extra darts. And then protruding off of the staff, there is this shape that we see repeated across the landscape that we have to have a name for it, so we call it a power bundle. But we see this shape with these two lines and this bulbous shape coming off on the other side. But most notably, this figure has red antlers with black dots on the end of the tines. It has a beautiful body, partially infilled, dashed outline. But it's these antlers with these black dots that really got our attention, because my collaborator, Carolyn Boyd, has interpreted these attributes as being related to peyotism, which is a sacred hallucinogenic cactus associated with creation and renewal by Native American groups. This is just one of hundreds of painted figures at a site called Halo Shelter in Texas. And this is a site we've studied periodically throughout the years, but in this past year, we spent 3 weeks of intensive field work at this site as part of the Hearthstone Project. And then many months later, in the computer laboratory and in the chemistry laboratory, studying this site. And so we're learning more and more as we go along. This is a figure that we are radiocarbon dating, and I'm not going to be able to tell you the age of this painting today. I did process the paint sample 2 weeks ago, and I'm waiting on numbers. And so as soon as we know, maybe that'll be a future lunch and learn. But we do know that the art at this site is somewhere between 1,000 to 4,000 years old. And that this style of art persisted for at least 3,000 years. And that's just mind blowing, I think, for many of us. And it's just really exciting what we're learning. But due to the specific attributes of this figure, we want to know exactly how old this figure is. So this is one that we are radiocarbon dating. I am showing you a false color image here using an application called D-Stretch. Many of you are familiar with this. You can use it on your phone or on a computer. And we use this technique in the field as well as at our computers. So with this project, we're really focusing on pictograph stratigraphy and chronological modeling. So we're looking at paint layering and how all the layers are put on a panel and the order in which the paint was applied to the wall. And then we're radiocarbon dating those specific paint layers. This project is, we have funding for 60 paint dates from 10 different murals in the region. And so in our first year of the project, we've conducted research at these 5 sites so far. We have completed both the fieldwork and all of the laboratory work at these 3 sites so far. And then we have done the field work and most of the lab work at Halo Shelter. And then, believe it or not, the team is actually in the field today. I'm the only one in the office today. They are starting the field work at Painted Shelter today. So this is kind of where we are in our first year. So in 2021, we sorry, I'm trying to mess around with some stuff. Okay, there we go. In 2021, we reviewed all the legacy dates for Lower Pecos pictographs, and we reported a handful of new dates that had been previously unpublished. And we also highlighted the advantage of some of the methods that we're using, the plasma oxidation technique, to radiocarbon date pictographs, which has actually been around for 30 years now. Makes me feel a little old, but this has been around for over 30 years. In previous research conducted by Marvin Rowe, who developed this technique, we do know that Pecos River style pictographs were created during the Archaic period, sometime between 1,000 to 4,000 years ago. But what we want to do with this new project is ask very specific questions. How old are deer headdress figures, and how do those compare to rabbit ear headdresses? Are they all from the same time period? How long were they painted? Can we compare sites from one site to another site? And so with improvements in the technique and our experimental design, we're really now able to get that data. And so this caused us to say, hey, we need to initiate a new radiocarbon dating campaign for the Lower Pecos. And we're doing that as part of the Hearthstone Project. The radiocarbon portion of the project is funded by the National Science Foundation, or a large portion of it. And then there is another portion of the project, which is focusing on iconography and the attributes of the figures, which it's all connected. We're going to be radiocarbon dating specific figures that have specific attributes. So we have to know about those figures and we have to know about those attributes. But that portion is funded by the National Endowment for the Humanities. And then this also is funded with many private foundations and donors. And I just feel fortunate that we get to participate in these projects. So the Hearthstone Project is named after the hearth, where you have a comal or a traditional Mesoamerican griddle that has 3 legs of support. And so with that 3 legs of support, we're saying that the Hearthstone Project has 3 branches of study: formal art analysis, archaeological science, and Indigenous knowledge. And it's really this interdisciplinary research that is the path forward. It's how we're going to learn the most information and do it in the best possible way. So because of who I am as an archaeological science person, I'm going to be talking about the radiocarbon portion of the project. But any radiocarbon dating project must be embedded in a robust documentation program. The organization just completed a 4-year effort to conduct level 1 documentation at over 235 sites in the region. But for us, the Hearthstone Project begins what we call level 2 and level 3 documentation and research at select sites. And we had done Shumla as an organization had done some of this in-depth recording at some of these sites previously, but what we're doing is making sure that these are now done with up-to-date technologies and methods as they have improved over the years. And so we're doing level 2 and level 3 documentation at the sites that I mentioned: Halo Shelter, Jackrabbit and Jaguar, 212340, and also today starting at Painted Shelter, which again, we have done some over the years, but we're making sure that we're doing things with some of the new technologies that we haven't been able to do previously. So our research design involves selecting those central figures that we want to radiocarbon date, those central figures with identifiable attributes that are repeated across the landscape, like the figure with the deer antlers and the black dots on the tines. That's not the only attribute we're looking at, but it is definitely one of them. For those figures, we will conduct a formal art analysis. We will document, we'll describe, we'll photograph, we'll illustrate those figures so that we have that documentation done. But then we'll move on to level 3, where we will conduct digital field microscopy. We use a brand name called a Dynolite. This is sort of a field microscope, a digital microscope. It has a USB on the end, and you can connect it to a tablet in the field. And so you can hold that up against the wall and you can start to see the order, you can see the paint layering. So here in this example, it's pretty clear the red is painted over the black. And so we can do this at hundreds of locations on the panel. And we could do that indiscriminately, but for this project, what we're doing is we're saying, okay, there's this one figure we're really interested in. Okay, how many figures does that one intersect with? And so we look at all of those points of intersection. Sometimes it's 50 locations, sometimes it's 100 locations, because there's so much superimpositioning at the panel. But we collect this microscopy data so that we can understand the superimpositioning or the paint layering at the site. Because it is at so many locations, instead of just kind of doing that in an Excel sheet or by hand, we use a computer program called Harris Matrix Composer. And our archaeologists are the ones that are entering this in. Carolyn's doing this. Diana Radiocarbon, Dr. Diana Radiocarbon is doing this. Some of our other archaeologists, Seamus Anderson is doing this. So we're putting all of this data in, and we're getting a flow chart or a map of all of the paint layering at the site. And for me, then I go, okay, so here's the central figure we're interested in. And they show me the flow chart that they've come up with. And then I say, okay, so what figures does that one intersect with that are overlapping? Because those would ideally be the same age, because they are overlapping with those and interwoven with different colors. But then I say, okay, what's the most bottom layer, the most bottom closest to the wall painted layer? And then what's the last layer that you think was painted? And so we sample not only from that central figure, but we sample for radiocarbon dating from that bottom layer and from the topmost layer. Now, if the mural is a composition painted all at the same time, we should get statistically indistinguishable ages. But if portions of that mural were painted at different times, we're going to be able to determine the entire chronology of the painting sequence at the site. So either way, this is super exciting, and that's the science part of it. That's why you do the experiment, because you don't know what you're going to find out until you do the science. And this is also I want to point out that this is a way that we can get the most information with the least sampling, because that's something we don't really like to do, to take a sample. But that's the only way we can get a radiocarbon date. And so this is a way to minimize that and still get the most amount of information. So the final product from each of these sites will be an illustration of the entire mural, or at least the portion of the mural that we studied. And our archaeologists will take copies of these panels to Indigenous groups in Mexico to seek their consultation and wisdom. What figures do they identify? And this is the thing I'm the most excited about, even though it's not the part that I'm doing, because I am so excited to share these murals that are here in kind of an isolated location with groups that are maybe further away, and see what we can learn from ethnography. I think that's really, really exciting. Okay, so now I'm going to back up and go, okay, how do we radiocarbon date rock art? So here's our science lesson for the day. Promise there's not too many molecules or chemical formula, I promise. But how do we radiocarbon date pictographs? Well, we use two different methods. So I'm going to talk about method one first. And this, I think, the most important way to date the art, and because it's directly dating the paintings. And we use a method called plasma oxidation to extract organic material from the paint. And then once we've extracted that organic material, it's radiocarbon dated using something called accelerator mass spectrometry, often abbreviated to AMS for short. So the plasma oxidation is what we do here in our lab at Shumla. And you can see that it is using electrically excited oxygen. You can see these copper electrodes on each side of these chambers, and the paint sample goes here, and you can see the plasma discharge, or the glow. And this is kind of like a neon sign where you run electricity through a tube of evacuated tube with a little bit of gas in it. And so that's what we're doing here. We're running electricity through this tube. And when we have a paint sample in there, we fill that with pure oxygen, and that oxygen reacts with the organic material in the paint and basically burns it and makes carbon dioxide and water. That carbon dioxide and water gets frozen in this glass tube right here, and it gets, we use liquid nitrogen to do that. So this is filled with liquid nitrogen, and this carbon dioxide freezes in this glass tube. And then we use a blowtorch to seal off that glass tube. So then we have like a little glass tube of carbon dioxide. That glass tube then gets sent to Lawrence Livermore National Laboratory, their Center for AMS, and they do the isotope measurement on that carbon. And so that gives us our age. Now, we use this technique, this plasma oxidation technique was developed to radiocarbon date pictographs. It's a method that is sort of perfected for dating pictographs. And that's because it extracts only the organic material from the paint sample. So if you have a paint sample sitting in one of these tubes, that paint sample is just sitting there. And the limestone and the oxalate, or the iron from the paint, it doesn't react. It just stays as a solid and stays in that tube. It's only the organic binders and vehicles that react with that electrically excited oxygen and then get turned into carbon dioxide. So we're only dating the organic component of the sample.
Oh, did we lose her?
I think we lost Karen.
Oh no! Hopefully she'll log right back on. Sometimes internet glitches can affect these things. Let me see. Just give me 1 second and let me just check with her. Poor thing. That's stressful.
That's one way of getting out of your talk.
That's right. Oh no.
Yeah, I'm watching.
We'll give her a second. Hopefully the internet just flipped and she'll be right back with us.
There's one question here I can't answer. The books in the plasma oxidation photo, are they just there for leveling, or do they have some other use? They're there because the lifts that would move those containers into place are about $100 a piece. So we use books.
But we did actually just receive a grant to purchase those, and she'll have to say what they're called. I think they're called jacks, to hold up the plasma, or the liquid nitrogen holders. So we won't be using books forever. We did just receive a grant for those, so that's exciting.
Jessica,
Take a new picture.
Did you reach Karen?
I did, yes. Her apparently she was not plugged in fully, and her computer battery died. So she's plugging in fully, and she'll be right back on. She said, "Give her 2 minutes. You can play charades." Donna Piercy asking if there was any damage from the recent rains. We're not sure is the answer. We're still not able to get to most of the places that we'd be most concerned about. There was such high water that we're anticipating that there probably was, but we are making plans to go out to those different sites and see if we can't assess the issues. But that was a very strange rain event, to have such a long drought and then have so much rain all at the same time. That's exactly the kind of rain that we worry about.
Okay, sorry everyone.
Awesome. All right, no worries.
We're all still there and riveted. I had a APC charger issue this morning and I thought I fixed it, but apparently I was on battery power, not plugged into the wall. So I am back. So are we good?
We're good.
Okay, cool. Thank you guys. Let me share my screen again, and I'm back to one monitor now, so this will be fun instead of two. But I should be able to start right where we were. So I think we were right here. And so we were just saying how, I was just talking about how we radiocarbon date rock art using this first method to directly get dates. And, you know, plasma oxidation is really an ideal method for dating rock art because it extracts that organic material, but it leaves those inorganic materials as a solid and they don't react. So the only part that we're radiocarbon dating are those organic binders and vehicles. So we do use a second method to date rock art also, and it provides minimum and maximum ages. And what we're dating are mineral accretions that are associated with the art. So let's see if I can get a laser pointer. So here, that you have this outer accretion layer that's outlined, and then in green underneath, we have this underneath accretion layer. And these mineral accretions contain something called calcium oxalate, and this is the oxalate anion, and it contains carbon that is from when that accretion formed. And so the radiocarbon data of this carbon in the oxalate that's in this layer and that's in this layer will tell me when did this layer form and when did this outer layer form. So we can get a maximum age if we date this underneath layer, and we can get a minimum age if we radiocarbon date the oxalate in this outer accretion layer. And then we can use that first method to date directly the organic material that's actually in the paint layer. And so I kind of call these sandwich dates, because you have, your 2 pieces of bread and you have your sandwich. So this is a second method that provides minimum and maximum ages. So we've done this at one site previously, and we were super excited when we got this data, but it's really preliminary. And what I'm going to show you today is just going to blow the socks off of you, or it did me, from this data. But let me show this preliminary data that we got at Eagle Cave. We have 3 direct ages on the paint. And then on the oxalate that's underneath, we have older ages. And then on the outer oxalate, we have younger ages. So for example, for this 1' sample, we have an underneath, we have a direct, and we have an outer. Now, if I didn't have this direct date and I just had this outer minimum age and this underneath maximum age, I would say that the painting occurred sometime in the middle. But because we're able to use that first method and get a direct date on the painting, that's really the most reliable, most trustworthy way of knowing the age of the painting. It's more specific on when that age is. But the advantage of being able to do the oxalate is that you're using a second test. You're using a second method to see if you're right. And that's what we want to do in science, is we want to keep testing ourselves and learning. And so here we're dating 2 different materials using 2 different methods, and we're getting results that agree. And so that makes us really confident that these ages are correct. So that was our preliminary data. So now what we've done is, with the Hearthstone Project, we've gone to these other sites. We've gone to Halo, and we have done the microscopy. And then they've taken that and put all of that information into those flow charts. We've processed those paint samples. We're just waiting on those numbers back. I'll probably have them back in about a month or 2. It can take upwards of 3 months to get those numbers back. But we're really excited about that, because we kind of have the whole picture at Halo, because we did microscopy across the whole panel. So eagerly awaiting that. But we have already, the archaeologist Carolyn has already created this wonderful rendering, and she knows the order in which each layer was applied for Halo. And so we're just waiting to put those numbers into that flow chart to see how that data looks. But we have already done all of this for Jackrabbit and Jaguar and 41 VV2340. And so we're really, that's what I'm going to show you today. So this is a figure at a Jaguar shelter here. And then this graph on the right, we're going to spend quite a bit of time looking at this. This is why I have my laser pointer. So these 5 results here are from Jackrabbit shelter. And then these 4 results here are from Jaguar shelter. One of them is from this figure on the left. And then this last date here is from a figure that's at the mouth of the canyon. Both of these sites, all 3 of these sites are in the same canyon. So 41 PV 2340 is right at the mouth of the canyon. And it has, the figure we radiocarbon dated actually looks exactly like another figure that is in Jaguar Shelter. And you see that all of those dates line up. Now, above these, we have the results from a smattering of other sites in the Pecos River style. That these are the results that I trust. And we have the 3 dates from Eagle are kind of in this one little blurb, but then we have single dates from 3 other sites. So what we're going to do is we're going to first look at, oh gosh, now I can't remember which graph I put first, but I think we're going to first look at these 5 results here on the bottom. Okay, so we're going to zoom in, and here are those 4 dates from Jaguar, and then the 1 date from 41 VV 2340 at the mouth of the site. And then what you can see is they line up really well. And I've shown these, I think maybe on my last Lunch and Learn, but I got new data to show you, so get excited. But these are basically 5,500 years old. That's phenomenal. This is the oldest dates we have for Pecos River style. But I was like, I really want to get those oxalate dates so that I feel like I really trust these results. And so that's what I'm about to show you. So just real quick, these are the weighted averages. If you averaged all of those dates together, you get this range. And this is CAL stands for calibrated. And this is the just regular BC that you're used to on your calendar. This is another unit that archaeologists use sometimes. Again, it's calibrated, but the BP stands for before present. And so this could be interpreted as years ago. And so that's why I'm kind of calling these about 5450, 5500 years old. Okay, so here is just the paint dates. But now what I'm going to do is we have a handful of oxalate dates associated with these, so that minimum and maximum. So let's see if I can. There we go. So here we have 1 maximum age, and it is older than its paint date. And then we have 3. This one is a outer. So it's younger than its paint date. And then we have this one that is an outer that is younger than its paint date. And we have this outer oxalate date that is younger than its paint date. And so these give me confidence that these paint dates are accurate. Now that they all lined up was a pretty good clue, but it's nice to have this second line of evidence. Okay, so now what I'm going to do is I'm actually going to go backwards. And we're going to look at these dates from Jackrabbit right here. And because I have so much data, I have to actually turn the graph on its side. So first, we're going to look at what we just looked at. So here's the Jaguar site dates, and there's their oxalates. So now here is the Jackrabbit paint dates. And again, I have them turned on their side. But these are the 5 paint dates, from Jackrabbit for 41 VV 576. That weighted average is here in BC and also here in before present. And I've got a red line kind of marking where that weighted average is. But in this instance, I have just the most complete data that we've ever had for a rock art site. We're going to have the under and the over for almost all of these. So here I'm going to add those in. Okay. So I know it's kind of complicated, but it's fun to kind of go back and forth. But you can see that all the unders are older and all the outers or overs or younger. If you want to just kind of break it by sample, you have sample 1 here. And again, if you just had the maximum age and the minimum age, you would know that painting occurred sometime in that gap. But we have that direct paint date that tells us when that happened, and a more precisely when that happened. We have the same thing for sample 2. We have the over, under, and direct date. We have the same thing for sample 3. And then for sample 4, we only have the outer. We don't have the underneath. But for sample 5, again, we have all 3. So here we have the direct paint dates, and this is the new data I'm showing you, this oxalate data that confirms that those paint dates that we had are correct. So this is something we are super, super excited about. So, if you want to follow along with what we're doing, please follow on our website, the Hearthstone Project. We have a blog where you can see updates about what we're working on, also on social media. And I want to thank my collaborators, Dr. Diana Radillo-Rolón, who's out in the field at Painted Shelter today, and then Dr. Phil Daring and Dr. Carolyn Boyd. And it's really all of us working together, the whole team working together. It's more than just the 4 of us that makes all of this possible. We have a new employee, Reedy Bainey, who's an archaeological chemist. He has a degree in chemistry and a degree in archaeology, and he's working with me in the lab. So I want to thank him. And then all of our staff at Shumla, who just make this a wonderful place to work and also allow us to do this work. So I'm going to thank you. I'm going to stop sharing my screen so I can see you guys again and answer your questions. But I hope you're as excited about those oxalate dates as I am.
On your map of the Lower Pecos boundary area, the zone extends to a corresponding area in Mexico. Is there a plan to perform a similar study of rock art south of the international boundary?
So, we get this question all the time because, it's so needed. And we are, working on that. It's hard because there's so much work to do. And so focusing our work, but we have Dr. Diana Radillo-Rolón, who is a Mexican archaeologist who is going to start actually working with Shumla next week full time. She's been a postdoc with Carolyn, and we recently had some documents donated to us that have more information than we had about the sites in Mexico. And so one of our goals is to go through those records and think about how we could approach that. But it's a long-term goal. It's not something that's just going to happen overnight, but it's absolutely something that we want to do. So let's see, I'm going to go kind of back up to the top and make sure I don't miss any questions that are in the chat. Somebody asked that they would like to know the age of the white shaman painting and the age of the culture that preceded it. In other words, what is the age of the cultural artifacts being represented there? So the white shaman site is Pecos River style. And most likely falls in that 1,000 to 4,000 year range. It was attempted to be dated back in the 90s by my former PhD advisor, Marvin Rowe. But the ages that they got did not statistically agree. They did average at about 2,000 years old, but there's some question on whether they were contaminated or not. And so that's a site that would need to be revisited if we wanted to specifically know the age of that painting. It's not a straightforward answer. It's a little complicated. Let's see. Okay, so the outer that have a younger date, does that mean that the painting was touched up later? Perhaps after some fading damage. Okay, so I want to be clear. So when we're dating the under or the over, we're dating natural mineral accretions that form on the wall due to weathering. So we're not dating actual paintings. So only that direct date on the paint is from the painting. And then we're dating a sort of a geological event that happened when we're dating the outer oxalate or the underneath oxalate. We do look for overpainting and try to avoid that because we don't want something that is a combination of two events. We want to date a single event. And so that's something you kind of have to, really look at the painting very carefully and under magnification and so forth. Oh, and you corrected yourself afterwards. Let's see. I know it says, will the lecture be available via link at a later date? And I know that they, Emil sends out an email with the video afterwards. So he'll do that. Let's see, Chester says, I read about Wellite, or it's actually Huolite, if you really want to know. It looks like Wellite because it's spelled with a WH, but it's named after a geologist, and his name was spelled that way, but it was pronounced Huol. So it's Huolite. And that is the calcium oxalate that we're dating. So here, I'll give you some chemical formulas just to drive you all crazy. I wish I could write them out, but calcium oxalate is CaC2O4. So C2O4 is oxalate. And Huolite is with one water attached to that. And then there's another mineral called Waddellite, which has two waters attached. But the part that's important, I kind of like to use the more chemistry word instead of the geology word, is the calcium oxalate. So it's just a matter of using the geology name versus the chemistry name. So let's see. Aw. Somebody said it's the most beautiful work ever done on rock art dating. Myself. What work has been done to determine the story the paintings tell? So as an archaeological chemist, I work with archaeologists that work on those questions, but I don't do that myself. I kind of stick to molecules and blow torches and things like that. But the Shumla's founder, Carolyn Boyd, has done a lot of interpretive work with this, and she's got several papers that you can go to our webpage and go to the publications link, and some of those papers are posted there, and they're free. We're sharing stuff after we're allowed to share it, and it's free. But then she also has published a couple of books on that interpretation, the most recent one being the White Shaman mural. And so it's amazing what she's been able to do with the connections between ethnography, looking at sort of shared symbols that are seen in lots of different groups, and then applying that to the rock art here. Let's see, how can, so, Peter asked, how consistent are the explanations offered by Indigenous informants? So we're in an area that the Spanish called the Despoblado, which meant when the Spanish got here, there was no one here. It doesn't mean that they weren't here. They probably just ran away from the Spanish. But my point is that we're also studying rock art that is 5,000 years old. And so we do talk to lots of Indigenous consultants. It's something we're working on, we're wanting to do more of. But there are, people that look at it and say, that's not my people, I don't recognize that. But then there are lots of people, especially the Huichol in Mexico, that have identified the figures and recognized the figures that are in the panels. So I'm not really answering your question, but just saying that there has been some work done in that, and we want to do more. It's something that's desperately needed. What is the paint? Okay, so the paint is made, I hope y'all are still cool and following along and all's good. The paint is, the color the pigment. So this is one of my little things. The word paint is something different than the word pigment. So pigment is what gives paint color. Okay, and so paint is made up of pigment, and it's also made up of binders and vehicles and solvents and other things. And so when we're doing the radiocarbon dating, we're dating the organic component of the paint, which would be most likely the binders and the vehicles. But the pigment in this particular area, and almost, to be honest, everywhere around the world that I've looked at people studying rock art, the pigment that causes the color are inorganic minerals. They're rocks that have color that are ground. So the reds and the yellows are ochres. And often the black is a manganese mineral. And that's true all around the world. You'd think if you wanted black, you'd just pick up charcoal from your fire and make a charcoal painting. But they were making good paint, guys, and they understood that they needed a mineral pigment to have a steadfast color. And so they were often using even manganese minerals for the black color. Okay, so Peter also asked, how do the paint dates compare to dates of archaeological deposits at these sites? So this area has been occupied for the past 13,000 years, and it's maybe not a absolutely continual occupation, but it's pretty close. And so, you know, that was the issue, is that you had 13,000 years of deposits in these rock shelters, and then you had paintings on the wall, and you wanted to know, well, when were the paintings made? And so that was why it was so important to be able to radiocarbon date the rock art. But yes, they do agree with the rock art. And one of the things that we're learning about the dates of the rock art is that there were technological changes that would have occurred in stone points and things like that, even though there are similarities in some of the things that we're seeing in the art. But that's what we want to do. That's why we want to focus on specific paintings, specific attributes of the paintings, so that we can connect that better to what's in the deposits. Okay, y'all asked lots of questions, so I'm rocking and rolling. Cole asked, are there any carvings in the area, images etched in the rock instead of painted on? They're not the predominant feature of this particular area. And most of the time they're quite different. The most famous site in the area is called the Lewis Canyon Petroglyph site. But even within rock art sites, we may see, you know, the most common petroglyphs we see are the etched lines, the crossed hatch lines, but not something that's figurative. You know, I'd love to try oxalate dating on petroglyphs to see if it would work. I just need to clone myself and have more time to do those kind of things. But yes, there are petroglyphs in there, but they're not the predominant kind of art that we see. Okay, so anybody else out there have any questions? I know I just sort of frantically went through those. I hope everybody enjoyed their lunch.
I've got to be getting to class, but thank you for answering my questions.
You're welcome, Cole.
Hi, Karen. I have a question. What about the portable art, the painted pebbles? Is there the potential to be able to date those?
Yeah, so that's something I'm also very interested in. That's my problem. I'm interested in too many things. But the painted pebbles are, for those of you who don't know, they're like river stones. They're yay big, and they often, there's different styles of those as well. I participated in a study a few years ago that analyzed the pigment in those painted pebbles. And we found that they're mainly black, though there is some red. And that the black, we determined, was painted with charcoal. And so that's really fascinating to me, that they would use something different for the painted pebble to create the black versus the black that's on the wall. With current excavations, we're able to get associated dates for painted pebbles where they're found in the stratigraphy. But unfortunately, there's so many painted pebbles that were excavated, in the 20s and earlier, or not much later, that we don't have the provenance of where those painted pebbles came from in the stratigraphy. And so it's hard to date those. And so the question is, could we directly date some of those? And that's something I'm fascinated with, because they're charcoal, and I think you could. Now, I messed around with the idea, would it be a horrible idea to stick a whole painted pebble in the plasma oxidation instrument and just remove like a little bit of surface carbon from that? I don't think that's the best method to go. And that's because these have been handled a lot. Some of them may have like the little painted numbers on them that we often write on like stone tools and things. And so I think because they're charcoal, though, you wouldn't need very much. And I think you could scrape off a little bit of that charcoal, and I think you could get a radiocarbon date on them. Nobody's tried that yet. But I think that, looking at the, that's somebody's dissertation, looking at the past stylistic models for painted pebbles and the proposed chronologies for those, and then, taking 2 or 3 pebbles from each style and doing some radiocarbon dating. And that would be a fascinating study.
Thank you.
Mhm.
Hello, can you hear me?
Yes.
Oh, yeah. Thank you so much for the presentation. And I love the work you're doing, and I love the teamwork that you've created in the Shumla organization. That's inspiring to me. It's still, yeah. So I've got, the age of the white shaman is 1,000 to 4,000 years old, and maybe around 2,000 years old, but we're not sure because of possible contamination. It hasn't been determined yet.
Mm.
But I'd also like to get a sense for when those people made that painting, how old was the culture that created that painting? In other words, I mean, Western culture, we can age it as back to Greece or whatever. What age range were they representing in their art?
So there's probably somebody that might give you a different answer, but I would say that there have been people living here, and most likely genetically the same people, though there may have been influxes of other groups, here for 13,000 years. And in the material culture, there's some changes in like how you make sandals or what stone tool you make, but we really, the sort of, my understanding is the leading hypothesis is that those are from introductions into the area. And so, there are archaic symbols in the art that are seen all across Southwest and even North America and South America. And so this idea of an archaic core, and this is what we learned from studying the rock art, that you don't learn from studying what's in the deposits, is that there are shared symbols, maybe how those symbols are executed or how they look are different, but they're shared symbols that we see across a large geographic area. And so that suggests to me that this is a very old culture. Now, somebody else that knows more about the dirt archaeology than I do might say something a little different, but I think having the rock art dates that span different changes in stone tools and how you make your sandals and things like that suggests to me that there was shared cultural beliefs being shared among groups in this area for a very long time. So I'm not giving you a specific age per se. It's something that needs to be studied more. But, I think that we're seeing the preservation of something that may have occurred in lots of other locations, but maybe wasn't always preserved everywhere else, or maybe the art was done on a different medium that didn't preserve. So I don't know, I could probably go on and on, but that's kind of my quick answer.
And I did see that we had one question about which are older, petroglyphs or pictographs. And so that came up in the chat, Karen. So I was gonna.
I would say I don't know because I haven't dated any petroglyphs. So I don't know. And hi, Marvin. Marvin Rowe is on. He's my former PhD advisor and my long-term mentor in plasma oxidation. So
Awesome. Well, I think that wraps it up then, Karen. You did awesome. It's so good to hear all this new research.
see you all.
Awesome. Well, thank you everybody for joining us. Stay tuned for our next Lunch and Learn. It's next we always kind of do the middle week of the month. And next time it'll be Dr. Diana Rolón doing her felines talk, but she'll be doing it in Spanish. So if you don't speak Spanish, skip October and we'll be back in November with a new topic. Ashley Busby will be talking about formal art analysis on the rock art.
Okay, thank you all.
Awesome. Thanks, everybody. Thank you, Karen.